So in this question, in a process, the number of cycles to failure decreases exponentially with an increase in load. At a load of 80 units, it takes 100 cycles for failure. When the load is halved, it takes 10,000 cycles for failure. The load for which the failure will happen in 5,000 cycles. So the given condition is number of cycles to failure decreases exponentially with an increase in load. That's the thing we have to note. That statement. The number of cycles to failure decreases exponentially with increase in load, and we have already given two data conditions. That first one is at a load of 80 units, it takes 100 cycles for failure, and when the load is halved, that means 40 units. Okay, 80 by 2, 40 units, it take 10,000 cycles for failure. The load for which the failure will happen, we have to find the load for which the failure will happen in 5,000 cycle. So let's look in how to solve it. So let's look in the given condition, and let us assume y be the number of cycle for failure and x is the load applied to be failed. Okay, load applied for the failure. Given y decreases, because they are already told number of cycle to failure decreases exponentially with the increase in load. So if I assume the y to be the number of cycle to failure, and y I can say it like y decreases exponentially with the increase in x. If y decreases exponentially with the increase in x, then the exponential function, a relation between y and x, will be y is equal to a e raised to minus bx. Okay, this is a statement. Okay, this is a fact. If it can be any two variable, it can be x and z, or y or w. If y decreases, the first term y decreases exponentially with the increase in x, then the exponential function between these two terms will be this form: y is equal to a constant a into e raised to minus bx, where the varying factors are both x and y. So apply this given condition to the apply this exponential function to the given two condition. First, they already told that there are 100 cycle for 80 load. So 100 is equal to a raised to minus 8b, first condition, and the second condition 10,000 is equal to a raised to minus 40b. Okay, given these are the two given condition for the respective cycle and load. So we have to find the third condition. Okay, they have already to find the number of load x for the number of cycle to be 500. For a 500 cycle, find the load to which this cycle failed. Okay, 500 cycle to be failed. Okay, after 500, how much load will take that after 500 cycle to be failed? You have to find the x for that condition. So that first of all we have to solve the condition for first and second case, and we will get b is equal to log 100 by 40. Okay, then divide equation 2. Okay, we can apply any two equation, though I will be taking equation 2, and the condition to be fine, I mean 500 equal to a raised to minus bx is the condition to be fine. So I will be taking that and dividing both two and substituting log to the base a 100 by 40 for the place of b, and finally solving we get the value of x at as 46.02. Okay, this is a simple question. All you need to know is the exponential function.